Hey everyone, welcome to Interview Node. In the next 5 minutes, you'll master the top 10 machine learning interview questions and pro answers to land your dream job. Let's dive in. Question 1. What is machine learning? ML is a subset of AI where algorithms learn patterns from data without explicit programming. For example, a model might predict house prices from features, minimizing loss like L equals sigma caret 2 for 1,000 samples. Question 2. Supervised versus unsupervised learning. Supervised learning uses labeled data, like an 80-20 train test split for classification or regression, aiming for an RMSE less than 0.1. Unsupervised learning finds patterns in unlabeled data, such as k-means clustering to identify 3 clusters, or PCA reducing 784 NIST pixels to 50 dimensions, retaining 95% variance. Question 3. Overfitting versus underfitting. Overfitting occurs when a model is too complex, fitting noise, resulting in 98% train accuracy, but only 70% test accuracy. Underfitting means the model is too simple, with both accuracies around 60%. Fixes include L2 regularization with a lambda of 0.01, dropout at 0.5, or adding more data. Question 4. The Bias-Variance Tradeoff. Total error equals bias squared plus variance plus noise. High bias, like a linear model on quadratic data, results in an MSE of 10. High variance, seen in a 10-fold cross-validation with a standard deviation of 0.2, indicates overfitting. An optimal model balances both, often achieved with 5 to 10 neighbors in KNN, yielding an error of 0.15. Question 5. Explain gradient descent. This optimization algorithm minimizes a cost function j by iteratively stepping in the opposite direction of the gradient, using the update rule theta equals theta alpha nabla j, with a learning rate alpha of 0.01. Variants include batch, stochastic, and mini-batch gradient descent. It typically converges in about 100 iterations, reducing loss from 2.0 to 0.01. With advanced optimizers like Atom using parameters like beta1 equals 0.9 and beta2 equals 0.999. Question 6. Common activation functions. ReLU, or rectified linear unit, defined as f equals max, is widely used in hidden layers for its speed and ability to avoid vanishing gradients, though it can suffer from 0.1% dying neurons. Sigmoid, sigma equals 1 slash, outputs values between 0 and 1, but is prone to vanishing gradients for extreme inputs. Tan, which outputs values between -1 and 1, has a mean of 0. Leaky ReLU, with an alpha of 0.01, addresses the dying ReLU problem. These are used in 99% of deep networks, like AlexNet in 2012. Question 7. CNNs for images. Convolutional neural networks, pioneered by Jan LeCun in 1989, use convolutional and pooling layers to capture spatial hierarchies in images. Key concepts include filters, stride, and padding. For instance, AlexNet, with 60 million parameters, achieved an 84.7% top 5 accuracy on ImageNet in 2012, largely due to parameter sharing, which reduces the number of parameters from billions to millions. Question 8. Evaluation metrics. Accuracy, calculated as /n, is not suitable for imbalanced datasets. For such cases, precision, recall, and F1 score are crucial. AUC, with a value of 0.95 at a threshold of 0.5, is excellent for binary classification. For regression, metrics like MSE of 0.02 and MA of 0.1 are used. A confusion matrix provides a clear visual breakdown of these metrics. Question 9. Feature engineering. This involves creating and transforming features to improve model performance. Techniques include normalization, like z-score scaling where mean is 0 and standard deviation is 1, one-hot encoding for categorical variables, binning, such as dividing age 0, 100 into 5 bins, and creating polynomial features like transforming x to x squared. These methods can boost accuracy by 15 to 20%, as seen in improving Titanic survival predictions by 12%. Question 10. XGBoost advantages. Extreme gradient boosting, developed by Chintianchi in 2016, is highly effective. It handles missing data by learning default directions, supports regularization with parameters like ETA equals 0.1 and gamma equals 0.1, and is parallelizable, making it 4 times faster than traditional gradient boosting machines. With typical settings of 100 trees and a depth of 6, it also features early stopping with a patience of 10, contributing to its 80% plus win rate on Kaggle. That's your top 10. These fundamentals are key to an 80% pass rate in ML interviews. Like and subscribe to Interview Node for more tips. Comment your toughest question below. See you next time.